Hi everyone, in this video we are going to be looking at applications of quadratic equations and functions in real-world contexts. In this lesson, you will learn how to formulate a quadratic equation in one variable to solve problems. Let us first take a look at Practice Now 14 found in your textbook page 30. In this question, it says that a diagram shows a structure in the shape of a triangular prism. A prism is an object or a solid that has a uniform cross-sectional area. In this case, the shape of the cross-sectional area is a right-angled triangle. We can see that it is a right-angled triangle because of the right-angle symbol over here. The base, which is triangle ABC, has dimensions as shown, whereby BC is x meters and AC is 8 meters. It is given that AB is longer than BC. Whenever we deal with a problem, it's important that we read through the question first to understand what is it talking about. Then, looking at part I, the perimeter of the triangle ABC is 17 meters. We want to write down an expression in terms of x for the length of AB. Following that, in part 2, we want to formulate an equation and show that it simplifies into this quadratic equation over here. In part 3, we want to solve the equation, leaving our answer to 3 decimal places. And then in part 4, we need to explain why we have to reject the answer. Finally, in part 5, we are given that the height of the structure is 7 meters, and we want to find the volume of the structure. So now that we have a gist of the question, let's dive into answering the question. So I have the question placed in small over here. I hope that you can still see it on screen. Otherwise, it would be great if you could refer to your textbook page 30 to have a clearer view. So in part I, we mentioned that the perimeter of the triangle ABC is 17 meters, and we want to find an expression for AB. So perimeter would include AB, BC, and AC. And AC, yes. So we know that in perimeter, it will be 8 plus x plus AB. Hence, using that information that we already know, we can form an equation like that. AB plus x plus 8 equals to 17. Since we want an expression in terms of x for the length of AB, we let AB be the subject. So AB is equals to 17 minus x minus 8, which simplifies to 9 minus x centimeters. Next, in part 2, we want to formulate an equation and show that it simplifies into this quadratic equation over here. So this idea about formulating an equation, we need to look back at what the question has given us. Earlier on, we mentioned that this triangle is actually a right-angled triangle. So what comes into your mind when you think about a right-angled triangle? I hope that you are thinking about Pythagoras' theorem. So in a right-angled triangle, we can apply our Pythagoras theorem, and what it tells us is that in this particular case, AC square is equals to AB square plus BC square. So we can make use of that to help us to formulate this equation that we need. So writing it down now, since triangle ABC is a right-angled triangle, we see that AC square is equals to AB square plus BC square, which if we were to include the expression or the values that we already know, AC is actually 8 meters, hence 8 square. AB was found to be 9 minus x, hence 9 minus x bracket square. And BC was given to be x, so plus x square over here. So our objective is to arrive at this simplified quadratic equation. Hence, I hope that intuitively you are able to see that we need to expand this and then simplify it. So upon expansion, we will have 64 equals to 81 minus 18x plus x square plus x square. Following that, we will have 0 equals to 81 minus 64 minus 18x plus 2x square. And finally, we will be able to simplify it into our 2x square found here, and then minus 18x plus 17. So you can rewrite the entire thing, okay, since they also asked to show it in this manner, so we just rewrite it, okay, and then ending it off with a shown. So this is how we formulate an equation by making use of the information that has been given to us, although it required some thinking and relating to what we already previously know. In this case, it was Pythagoras theorem. Then, now we look at part 3. Part 3 only says that we want to solve the equation. So this is a quadratic equation to solve, and we have various methods to solve. The most efficient method that we know so far is to use the formula. Hence, when we apply the formula after identifying the value a, b, c, we will find that x is equals to this, and pressing it into our calculator, we will be able to get 7.9278 or 1.0721. But keep in mind that we need to leave our answer to 3 decimal places. Hence, I will get 7.928 or 1.072, and then ending it off with 3 decimal places. So now that we have these values, we notice that the two values are both positive. Okay, I do not want you to think that every time we receive a negative answer, we need to actually reject that. Okay, we need to always link back to the context of the question and decide which is the value that we need to reject. Although in part 3 itself, the question asks us to solve, we need not do any rejection, but in part 4, the question expected us to explain why is it that we need to reject one of them. So, which of the value over here should be actually rejected? So, going back to the context, we think about what are the information that has been given to us. There's this critical information here that says it is given that AB is longer than BC. So X, what exactly is it? X refers to this length BC. Okay, so what will happen if X were to be 7.928? What happens to the length AB? And if X were to be 1.072, what is the value of the length AB? We know the expression for length AB to be here. So if we were to do a simple calculation, we can determine under which circumstances will it not satisfy this sentence here that says that AB is longer than BC. So I hope that you are able to deduce that we need to reject X is equals to 7.928 as AB will be 9 minus 7.928, which is equals to 1.072 cm, which is shorter than BC. Okay, so this reason helps us to learn that we need to reject X equals to 7.928. And then to the last part, part 5, I'll move on to a new page. Given that the height of the structure is 7 meters, so keep in mind this is a prism. The height refers to the point B all the way to the base. Okay, otherwise it can also be from point C to the base or A to the base since the height is uniform. Okay, we want to find the volume of the structure. So we first find out what is AB. Okay, which is 9 minus 1.0721 since we have earlier on already rejected the other answer. So AB is equals to 79. So volume for a prism will be half times base times height of the triangle, then times height of the structure itself, because we need to find the base area of the triangle, then times height. So the base area, which is the triangle, it will be half times base times height. That will be half times 1.0721 times 7.9279, followed by times 7, and then we will get 29.748, and finally 29.7 meter cube after rounding off to 3 significant figures. At this juncture, I would like to pause for a while. Okay, so given that we earlier on found the values of X, okay, although the answer here was, or rather the question here asked it to be left to 3, or rather asked it to be corrected to 3 decimal places, okay, in our intermediate step, we should use a higher accuracy, for which I have used 4 decimal places or truncated 5SF, okay, for my subsequent calculation. Alright, rather than using my 3 decimal places calculation. This will give me a more accurate answer. Okay, so this is our accuracy practice. So I hope that we are all aware about that. Then at the end, we will leave our answer to 3 significant figures. That is as per the expectation for our exams. So with that, we are done with practice now 14. We will now take a look at practice now 15. It says that Bernard drove 600 kilometers from city P to city Q. So there are two cities. The average speed of his return journey was 7 kilometers per hour faster, and the time taken was 15 minutes less. So we take note that this second statement is talking about the return journey. In part I, it says that if he drove at an average speed of X kilometers per hour on his journey from city P to Q, we want to write down an equation to represent the information that has been provided and show that it simplifies to this. Typically, when it comes to a problem that involves speed, distance, and time, I like to draw a diagram to represent the situation. So this is how I would draw my diagram. I will first have my city P to city Q, indicating that they are 600 kilometers apart. Then the question told us that from P to Q, it is going to be traveling at X kilometers per hour. Then from Q to P, it was mentioned that it is 7 kilometers per hour faster, and therefore it will be X plus 7 kilometers per hour. Okay, I did not include the 15 minutes less information. I'll keep that in mind first, okay, for us to use. So this diagram, okay, does kind of help me to keep in mind what is the information that I've already been given, and also the direction of movement and the speed involved as well. So I'll shrink this diagram and shrink the question to the next page so that we can do our working. Okay, so the diagram is over here. So now, okay, the only information that we have not made use in the diagram is the idea of 15 minutes less. Okay, we know the distance of P to Q, we know the speed from P to Q, likewise we also know the speed from Q to P. So if you recall your DST triangle, okay, which we learned in primary school, let me just grab a pen out to write it on the screen. Okay, so sorry, let me just erase that first. Okay, so if you recall your DST triangle, okay, so because we're trying to find out the time, okay, how do we express the time over here in terms of the distance and speed? We know the distance, which is 600 kilometers. The speed for one direction of the journey is given to be X for P to Q, whereas for the other one, it is from Q to P. So I can form expressions for each part of the journey. So the time taken from P to Q would actually be equals to 600 distance kilometers divided by X, which is X kilometers per hour. And keep in mind that the unit involved for the time taken is actually in hours, because our speed was in kilometers per hour. Then the time taken from Q to P would be 600 kilometers, which is the distance as well, divided by X plus 7, which is the speed from Q to P. So now that we have formed the respective expressions for the time taken from P to Q and Q to P, I know that the difference in time is actually 15 minutes less. Okay, so our Q to P, this one, is 15 minutes less than P to Q. So that means that 600 over X is greater, okay, while 600 over X plus 7 is smaller. Hence, the expression or the equation that we need to think about is 600 over X minus 600 over X plus 7. And this difference is actually equals to 15 minutes. However, just in case you're already thinking that this is the correct equation to form, I want us to think about the units, because if you heard me just now, I was placing a lot of emphasis on the units involved. The time taken over here is in hours, but 15 is actually in minutes. So if that's the case, we cannot equate these two quantities to be equal together, because on the left side of the equation, this is actually in hours as mentioned, and on the right side it is actually in minutes. So it is incorrect to actually equate them when forming an equation, because when it comes to equation, the values need to be equal, and for the values to be equal, the units need to be equal. Okay, so how should the equation then be formed? We have to ensure that the units are the same, okay, on both sides of the equation. It will be extremely challenging to actually convert the expressions on the left into minutes, okay, because we will end up maybe encountering very large numbers, or maybe some of you are not that great in handling fractions. But it is definitely easier to convert this 15 minutes into hours. So we will take that approach. So my correct answer is going to be expressed in green, okay, from now onwards. So these two statements here are correct, but then this statement here is not correct. So the correct equation to form will be 600 over x minus 600 over x plus 7 equals to 15 over 60, for which in order to solve, we will have to make the denominator, okay, on the left to be of the expressions on the left to be the same. That will be to get a denominator of x times x plus 7, okay, and then 15 over 60 simplifies to be 1/4. So I will want to actually expand the numerator first, and we'll get this. Likewise, I'll expand the denominator, and then I will do my cross multiplication, for which concurrently I have also simplified the expression in the numerator here, where 600x minus 600x is equals to 0. So I'm left with 4200 multiplying by 4, and then 1 times x squared plus 7x. And I'll expand this and simplify it. I'll get x squared plus 7x minus 16,800 at the end. And that is how we show that it simplifies to this. Next, we take a look at part 2. We want to solve this equation. So I hope you notice that even though in the problem itself, if you have the difficulty in forming, okay, the equation and expressing it into the simplified form, if you have that difficulty in doing that, part 2 will not actually be a problem, because we are fully capable of solving a quadratic equation the moment we know how to apply our formula. So I hope that you don't actually sacrifice your entire question just because you don't know how to do part 1, because part 2 and part 3 are likely to be manageable on your end. So looking at part 2, apply our quadratic formula to this equation. I will recognize that A, B, and C are as such that my formula is going to be applied this way. Okay, sorry, this is negative 16,800. Okay, sorry for my bad computer handwriting. And then it will be simplified into this exact form such that I can calculate my truncated 5SF value. Although in this case, I did not do truncated 5SF, because in the case of truncated 5SF, I will actually already get 2 decimal places. So in such cases, I will take 1 more decimal place, okay, or 1 more significant figure, depending on the question itself. So I'll just get 1 more digit, okay, before finally rounding it off to whatever the question has asked for. Okay, so we get 126.16 or negative 133.16. So that's our answer for part 2. Then we take a look at part 3. We want to find the time taken for the return journey in hours and minutes, giving your answer correct to the nearest minute. So keep in mind that we're looking for the return journey, and earlier on, the speed of the return journey, if you recall, is x plus 7, which in this case, with the x value, we take 126.16 plus 7, and we will get 133.162 km per hour. At this juncture, I'd like us to pause for a while and think, why is it that I took only x to be 126.162? Why did I not take negative 133.16? I hope you know the answer. Okay, the reason is actually because we're trying to determine the speed over here, and in the quantity speed, it cannot actually be negative. That's why we have to take the positive value and hence rejecting the negative value. So we need to have the reason in our mind even though the question did not ask for a reason itself. Okay, we cannot just randomly decide or go with the usual habit of rejecting negative. It is actually not true that all the time we have to reject negative value. Sometimes we actually need the negative value and reject the positive value instead. Then from here, the time taken for the return journey will be distance divided by speed, and the distance was 600. So we will take 600 divided by 133.162, and we will get the time to be 4.5057. The question wanted our answer to be left in hours and minutes, so this is actually in hours. Okay, to express it into hours and minute, it will be 4 hours, that is the whole. Okay, and the minute, the decimal portion, needs to be multiplied by 60 in order to convert into minutes. And we actually get about 4 hours 30.342 minutes, but we expected to correct to the nearest minute, and that will actually be 4 hours and 30 minutes. So that is our answer to practice now 15. So now that you have gone through 2 examples, you may want to pause the video over here to give this question a try. This question is found in your textbook page 33, and this is question 2. You may wish to give this question a try first before looking at or hearing out the answer that I'll have to present to you for this question. So in this question, there are 2 printers in a library. Printer A prints 60 pages every X minutes. We want to first write down an expression in terms of X for the number of pages printed by printer A in 1 minute. So let's deal with question part I first. Okay, let me just shrink this question down so that I have more writing space. So the number of pages printed by printer A in 1 minute will actually be 60 pages divided by X. Okay, then in part 2, it says that printer B takes 2 minutes longer than printer A to print the same number of pages. That means that 60 pages takes X plus 2 minutes. We will also want to write down an expression in terms of X for the number of pages printed by printer B in 1 minute. So applying the same logic, we will take 60 divided by X plus 2, and then we get the number of pages per minute. Moving on, we are told that when both printers are in use, they are able to print a total of 144 pages in 1 minute. We want to write down an equation in X to represent this information and show that it simplifies to this. So let's try to understand this statement over here. It says that both printers are in use. So that means that in 1 minute, printer A itself can only print out this number of pages, while for printer B, it can print out this number of pages. If it is being used together, how many pages can actually be printed out in total? That will actually be the sum of 60 over X and 60 over X plus 2. And this sum over here is actually 144 pages, because this is the total number of pages to be printed when both printers are used in 1 minute. So using that information, we can form our equation to be as such. Now we need to actually simplify it and form a quadratic equation. So for the fractions on the left, we can create a same denominator, and that will be getting this over here, followed by doing our cross multiplication, or perhaps you want to expand the numerator and denominator first. Okay, so in this case, I have expanded the numerator, and concurrently I have done my cross multiplication where I take x times x plus 2 over to the right, and I get this. Then I will simplify it and expand, and I will get this quadratic equation of 144x squared plus 288x minus 120x minus 120. I could simplify it further to arrive at this, but you may be wondering, why is it that this equation here differs from this? I hope that you recognize that we can actually further factorize out a certain factor over here. In this case, we can factorize out 24, and that will leave us with 6x squared plus 7x minus 5. So when I divide 24 over to the right, I am going to arrive at the quadratic equation, which is what I'm expected to show. Then in part 4, we want to solve the equation 6x squared plus 7x minus 5 equals to 0. We use our formula and then continue to solve the equation itself. So we will get 0.5 and negative 1 and 2/3. Okay, the formula may not always be the only way to solve the quadratic equation. We know that we can do factorization. So if you could see that this, if this to you is easily factorizable, okay, depending on how skillful you are in your factorization, you may be able to notice it right away. So you can also do your factorization method. You need not always do the quadratic formula method. But whichever method you use, you must demonstrate the working, you must demonstrate your understanding by showing clear working to it. Then moving on to the last part, we want to find the time taken by printer B to print 144 pages. So for printer B, we know that in 1 minute, it can print 60 over x plus 2 pages. That means that x is going to be 0.5. I hope you know why I only took 0.5. Because x is referred to be time over here, and time cannot actually be negative. That is the reason why we did not consider it in part 5. Then, so 1 minute, printer B can print 24 pages. So in order to print 144 pages, we will take 144 divided by 24 to find out that it requires 6 minutes. I hope that you are able to solve this question on your own. Otherwise, I hope that this explanation is helpful in getting you to understand this question itself. So likewise, after going through several examples already, you may want to pause the video over here to give this question a try. This is found in textbook page 33, and that is question 5. So in this question, it says that a model of a commemorative structure in the shape of a square-based pyramid has a scale of 1:100. The diagram shows one of the lateral faces of the model where AP is equals to x plus 5 and BC is equals to 2x. Okay, at this point, looking at the question itself, I hope that you are not deceived to think that we are talking about a triangle. Okay, because the question mentioned that this is a square-based pyramid. This is only a triangle. A pyramid is a 3D solid. So what we got to do is you can draw out your own pyramid to help you visualize the question itself. This triangle is only one of the lateral faces, and lateral faces actually refer to the triangles that are around the pyramid. So let us draw a pyramid out. Okay. So this is how a pyramid could look like. I will indicate the apex to be A, okay, followed by B to be here and perhaps C over here. It really doesn't matter whether you have A, B or C here, or you can have the other triangle. Okay, choose the triangle that can best help you visualize the question better. So I've chosen this triangle that's on the right surface or right side of the pyramid. Okay, and this triangle is actually what is being provided over here. So the length BC is actually 2x okay, sorry that my animation is kind of coming out slowly. Okay, and then keep in mind that this is a square base pyramid. So this base over here, okay, is actually a square, which means that BC is the same length as this length here. Likewise, it is the same, okay, for all the lengths around this square. Okay, I'm going to highlight this triangle ABC so that we can do that comparison to what we have been provided in the diagram here. And then the length from A all the way to the base BC is actually P. Unfortunately, my diagram seems to make it look like this triangle ABP is not congruent to triangle ACP, but actually it is congruent, just like what is being demonstrated here. So P is actually the midpoint. It divides BC into half. Okay. But I think that is not an important information for us to solve the remaining parts of this question. However, this diagram is very helpful for us to understand the entire question at this stage. So, and I also forgot to indicate my AP over here, which is x plus 5 cm. Okay, oops, I'm sorry, let me go back. Okay, so in part I, we want to write down an expression in terms of x for the total surface area of the model. So this is the model we're talking about. The total surface area consists of 4 triangles, okay, for which all the triangles are congruent, okay, and also the square base. So if I can find out the area of one lateral surface, meaning to say the area of one triangle, which is half times base times height, that will be half times 2x times the height x plus 5. I will be able to get x times x plus 5, and it expands out to be x squared plus 5x. So that's the area of one triangle, one lateral face. There are 4 triangles in total, so to find out the total surface area, I will take 4 times x squared plus 5x, okay, and also the area of the square, which is 2x times 2x, okay, and then I can expand this and simplify it. I'm sorry that my animation isn't coming out right. Okay, so we have 4x squared plus 4x squared plus 20x. And that simplifies to 8x squared plus 20x cm squared. So this answers our part I question. It is the expression, okay, that represents the total surface area of the model. Moving on to part 2. Given that the total surface area of the model is 50 cm squared, we want to formulate an equation. So earlier on, we already have this. So this is actually equals to 50 cm squared. That is what part 2 is telling us. So I can use that to form my equation. Okay, then I can bring the 50 over to the left to form 8x squared plus 20x minus 50 equals to 0. And then simplify it to get 2 times 4x squared plus 10x minus 25 equals to 0. And I could divide away the 2, and that allows me to show that it reduces to this. And part 3, we can apply our formula A, B, and C, find out, or rather apply our formula minus B plus minus square root B squared minus 4AC over 2A, and that gives us a value of 1.5450 or negative 4.0450. This is a truncated 5SF value. The question did not specify how many places or what's the accuracy required. When that is the case, we will leave our answer to 3 significant figures. Okay, so this is our answer. Right, and then in part 4, we want to explain why one of the solutions in part 3 must be rejected as the length of BC. Okay, so we have, by considering the BC itself, okay, if x were to be negative, we know that BC ends up becoming negative. Okay, so therefore we will say that x equals to negative 4.05 must be rejected because BC and AP will be negative in value when that is the case. However, as they are length quantities, they cannot be negative. Hence, that value must be rejected. Okay, I wrote something extra over here, actually, because the question says that, rather stated very specifically that it is to reject due to the length of BC. Actually, you do not need to really write down an AP. Okay, so this part over here is kind of an extra. Maybe let me bring out a pen to cancel it. Okay, so you don't really quite need this. Okay. Then in part 5, I'll move on to a new page for me to write more working. In part 5, we are told that we want to find the actual floor area, take note actual, in meters square, that the commemorative structure occupies. So going back to the question, what was it talking about? It is talking about that the dimensions or the things that are given over here is only for the model. Okay, the actual structure obeys this scale of 1:100. Right, so we want to know the actual floor area. The actual floor area actually refers to the square base of the pyramid. So if I were to go back to my diagram of the pyramid, okay, this is the floor area, because this is the only part touching the floor, right, the square. So sorry, let me just zoom past this. Okay, the base area of the model will be 2x squared, because that is a square. Alright, so 2x times 2x, that gives us 4x squared. So using the value of x that we had found, that will be 1.5450. We will find that base area is 9.5481 centimeters square. But this is only for the model. We want the actual one. So recall what we did in Sec 2 when we learned about map scales. So the map goes with a value of 1 cm. The actual is 100 cm based on this ratio over here. 100 cm is actually 1 meters. So now that we are looking for area, that means that 1 square cm square is representing 1 square meter square, and hence 1 cm square is representing 1 meter square, and therefore the actual floor area will be to take this base area to multiply by 1 meter square, which coincidentally is 9.5481 meters square. Okay, and then we leave our answer to 3SF. Sorry, I realized I missed that out. Okay, let me just write it in now. Okay, so we leave our answer to 3SF. Okay, we will get 9.54 meters square. Oops. Alright, so hope that is clear. And that's it for this unit. Okay, I hope that you are able to formulate an equation on your own and try out these questions yourself, okay, especially the ones found on textbook page 33. Otherwise, I hope that you can give the remaining questions in the SLS lesson a try to check your understanding. I'll see you in the next lesson. Bye bye.